It's Q&A Wednesday! So we've got to answer a question today.
Yeah.
And this question we've actually been thinking about for a few days now.
Yeah, we have.
It's a really good question by a gentleman named Justin Shook.
Right.
Who works for Superior Gunite. He's a shotcrete superintendent and a certified nozzleman in the Littleton, Massachusetts area. So Justin,
thank you for your question.
Here it is. Ding! How does paste content affect durability and permeability? And how does the size of the coarse aggregate relate? Excited to answer this question.
Yes.
And we've broken it up into two categories. We're going to focus on the paste first, then we're going to dive into the MSA, the maximum sized aggregate, and look at both of them individually as permeability, or for durability, permeability, and then wrap them both up, connect the two.
Sure.
Okay, so first and foremost, the cement paste of the concrete composite.
So the hydrated cement matrix is the glue that holds the concrete together. So that's the gray stuff around all the aggregate.
Yeah, and when you look at a composite material, Hull and Klein define a composite material as a material containing at least two materials.
Mm-hmm.
So one is a matrix that surrounds a stiff and elongated aggregate or fiber. In our case, it's the rock and sand surrounded by the cement paste. Now, that cement paste, that glue, is a very, very porous matrix, and it's almost easy to call cement, or that hydrated cement, a hardened sponge.
Agreed.
So that being said, we're already starting with porosity, and that permeability normally leads to more aggressive materials.
Sure.
And what is
Assuming you don't optimize the mix. And
well, that's what we're talking about. Yeah, and
but just kind of a basic mix, absolutely. It's very porous, very permeable.
And the hydrated cement matrix is always going to have some porosity to it.
Absolutely. And then concrete's always going to take in water.
And that hydrated cement matrix, I mean, that, even though it's the glue that holds concrete together, it's also the part of the composite that is more susceptible to deleterious attack.
Right. Agreed.
Right. So either you have your bleed channels that come through the cement paste that leave that bleed water, and those bleed channels can act as highways for more aggressive material to get to the steel, or you have your alkalis that contribute to alkali-silica reactivity by consuming the silica on the surface of the aggregate.
Oh, absolutely. And then, with your concrete, I mean, you've got stuff happening on top and stuff happening from the bottom, so it's kind
that
of
restraint, the cracking,
getting hit everywhere.
So the question is, how does cement paste relate to permeability and durability? And Whitney already alluded to, it might be the most porous part of our mix. It might be the most susceptible, but it also holds the greatest opportunity for enhancement.
Right.
So. Whether you reduce your water cementitious ratio, add a little high range, or
add mixtures and additives to increase strength and durability.
Totally. I'm going to Australia this week to talk to a bridge assessment conference.
Yep.
And I'm talking about my PhD research, the use of colloidal silica to increase the strength and durability of concrete. And colloidal silica, silica fume, fly ash, slags, metakaolin, alternative binders are great at tightening up that matrix and reducing the migration of aggressive materials. And that's for paste. That's where I guess they go hand in hand, where permeability or lower permeability often leads to a greater durability.
Oh, absolutely. You've got less that's coming in to be able to break down the concrete. So definitely, the tighter it is, the denser it is, the more durable it's going to be long term, unless there's some sort of significant structural issue with it. That's a whole nother problem. But
understood. So going into the next one then, size of the aggregate. And we just did some pervious mixes where we used a 3/8 inch aggregate, and then we used a 3/8 inch is around how many millimeters? 9 to 10 millimeters.
Yeah.
And then we did another pervious grout, which is leaking water all over me. But we used a 1 to 2 millimeter aggregate, and I can tell you that the difference that I saw was the amount of paste that was needed to cover the surface area.
Sure.
So the larger your aggregate, normally the less paste you need to coat that
Because
aggregate.
your surface area is much lower of your aggregate.
Right, and then also the smaller your aggregate, the more the phenomena of the wall effect. Do you know what the wall effect is?
The Van der Waal effect, right? You've got your charges. That's not what you're talking about.
The wall effect, and it's published in A.M. Neville's concrete book.
Okay.
I believe it's in like the 200s or the 300s. But as you get closer to the surface of your aggregate,
Okay.
the more surface area that you have, and the more paste that's going to be used up as you get closer. So the closer you get, the less paste there's going to be, and that interfacial zone is going to have a little bit more porosity to it than if you go further away from it into the body of the concrete or away from the rock surface.
Right.
So when using a larger aggregate, because you have a lower surface area, normally...
You're getting better binding of the paste to the aggregate.
That being said, I wanted to take it a step further.
Sure.
Instead of saying the maximum size aggregates impact on permeability and durability, I want to talk about the porosity index.
Sure.
Because it's not just about the size of the aggregate, but it's the refinement of that, sneeze on the tree, that granular step tin that's going to have an impact on the concrete. We saw this as a huge part of the SCC movement, self-consolidation movement, where you took a room, you filled it up with bowling balls,
Right.
you had a certain porosity where they touched. If you removed half of those bowling balls, replaced it with
Baseballs.
and then half of that and replace it with
Golf
balls,
balls.
and then half of that and replace it with marbles, you would refine that porosity index. And how that helps us is the more you refine or reduce that porosity index, the more or the less paste you need
Right.
to coat or to fill up those pores and give you the consolidation or the slump that
Well,
you
then
need.
you've got all these aggregates that are filling in so many of those pores, so there's just less pores to deal with in general.
Right.
And then you're also increasing your workability and other things. But
Making the mix more robust.
Right.
But going back to permeability and durability, we mentioned earlier on that paste is, I mean, it's the glue that holds concrete together, but it's also the most susceptible to deleterious attack. And then if you add extra water, it increases the porosity.
absolutely.
So that being said, if you can refine that porosity index, use a lower amount of binder or cementitious paste,
Right.
increase the amount of rock and sand, and
Right,
make
you're
it more robust.
Decreasing permeability and porosity and all those things just because there's not as much needed. Cool.
Okay, I think we've wrapped up Justin's questions. Thanks,
Thank you
Justin.
again. Great questions.
Great freaking question. If you have any other questions based off of anything we've said, please feel free to shoot us. We've got a few more questions to address in our next Q&A Wednesday that Whitney and David are going to be addressing. So, go concrete!
Beat asphalt.